on your camera, please, because people remember people by our faces, and I guess it will be better when we will see each other. You don't need to wait Q&A session. It's a meetup. We can ask questions like in real life. We need to create like dialogue. And be open, don't be shy, and show your personality. Maybe today you will find your calling in life. So today we have 45, I guess, minutes of data science cases, and rest of time will be for Q&A session, like officially Q&A session. You can ask something, you can ask, I guess, everything our experts from DataLab. And today I would like to welcome our experts like Elżbieta Sienkiewicz, Wróblewska Anna i Przemysław Biecek. So you're welcome.
So I think it's a great moment to start the presentation, and I'm very happy that you guys joined us today.
Yeah. Thank you for the invitation. Let me start. I hope that you can see my screen and you can hear me well.
Yes.
Excellent. So again, thank you for the invitation. I see some faces. That's nice. I guess that most of you are students, so you are much younger than me, and it's good because the approach that we are going to take is to share with you our experience, because I remember being a student, it's like a time in life which is very important, because you can make a lot of decisions and usually you don't know which decision you should take. So the best advice is to listen for many people, learn what they are doing, and kind of decide what you would like to achieve in 10 years, or 20 years, or 30 years, thinking about your future. So I'm really glad that you invite us, people from academia, because mostly on such meetups, I see a lot of companies. I see a lot of large companies, small companies, startups, corporates, but not that many research groups. So again, thank you for the invitation. And also, I hope it will be a discussion, so interrupt me anytime. If you have any question, don't be shy, interrupt me and my colleagues anytime. We are here to talk with you. We have few slides, but it should not be a one-to-many monologue. It should be a discussion. So first thing is that the agenda. Then agenda is following. My name is Przemysław Biecek, and I will start the discussion. I will spend more or less 50 minutes to talk with you about a single project, research project, and I want to convince you that working at academia is not only about teaching, but it's also about some other things. So I hope this will be interesting. And then to my colleagues, we'll talk you about maybe some very detailed, very interesting use cases on which they are working right now. So I hope this will be interesting. Before I will go further, I just need to say that the way how we should pronounce our lab is MI², because it comes from the square. It comes from names of two faculties from which people are joining to our group. One is Mimi from Warsaw University of Technology, our department, and second is Mim from University of Warsaw. So these two groups are in both departments. You will find mathematicians, and in both departments you will find a great computer scientists. And I thought that it would be fun to split these two names together, but to avoid problems which name should be first, it turns out that you can use MI from both names and add square, and this will kind of combine both departments. So the proper name is MI², And I hope that this will be the first thing to learn from this discussion, but not the last one, and not the most important one. Okay, so let me start. Let me start, and then be prepared that these three parts might be very different. Like I will be sharing kind of maybe this will be probably more philosophical discussion, but then you will see some concrete examples. So if you prefer some concrete examples, don't leave right now. Wait 15 minutes. If you like philosophical questions, you are please interrupt me and please make it like a dialogue. Okay, so sharing a story, it's about maybe sharing a story from some perspective. So maybe I will tell you why I'm working at academia, but to tell why I'm working at academia, I will also tell you where I was working and why I stayed here. So few words about my experience, maybe from the bottom. I like sharing information from others. So 10 years ago or something, I started NGO, non-government organization called Smarter Poland. It is a foundation designed to spread information about data science for the, let's say, Polish community. And we were doing some meetups and many interesting things, but yeah, it took like 7 years. Then I also, I think that many of us are hearing about these cool startups. So for me, it was very tempting to also start a startup or join a startup. So 15 years ago or something, I've joined Positive Advisory, a small consultancy company. And then after a few years with my colleague, I started Data Hero startup. It was more or less about joining young people with companies and choosing the best candidate for work for the proper company. It was kind of interesting startup. And a few years ago, I started with my colleagues another startup, Data Donuts. These startups do not exist right now, but it's with most startups, like they have on average very short lifespan. Also, I was working for larger companies, and it is actually a very interesting experience because all these companies, to operate on scale, they need to have a very good processes. So first, it was a Netisa, a nice company that is working on advanced analytics. They were provided by of large mainframes. Then they were acquired by IBM. I guess that you heard about IBM. Then I joined ICOR. I forgot that I was working for 3 years for Disney. And actually, Disney was a very interesting use case because Disney is most about the creative environment. It was really fun to work there. Last 3 years I've spent in Samsung, so lots of experience in the corporations. And again, you can learn a lot there because they operate on a really large scale. So you can learn a lot about processes that help to exist on a large scale. Yeah, but more than 50% of my life I've spent at academia. And my PhD, I did my PhD in Wrocław, University of Technology. Then I moved to Polish Academy of Sciences. Then I moved to University of Wrocław. Then I moved to Warsaw, working for 13 years, a lot of time, at University of Warsaw, and last 6 years here at Politechnika. So more than 50% academia. So I am a person from academia, and I will tell you why I choose this way. So in my mind, the work at academia consists 2 parts, and they kind of complement each other. One is teaching, and I guess that this is something that is most visible for you, for students, because this is how you learn or meet researchers. But actually, I think that for many researchers, they spend time mostly on research. So there are these kind of 2 perspectives. And when you talk with people, it's very common that they work in different positions. So they can work on fully research-oriented positions. So you can be a researcher and you may have 100% of your time paid from some research projects. You may be a 100% teacher. Okay, it wasn't me, I hope. So 100% of your time may be paid from a teaching kind of part of the department. Yeah, and you might be somewhere in the middle. So it's really nice because it's very flexible. You can kind of move from one direction to second direction. If you feel that you like teaching, you can always take more hours of teaching. If you feel that this year you need to rest because you are tired, it's very common because it's really easy to burn out. So it may happen that after a few years, you would like to stop teaching for some time. It's also okay, you can move to these research positions. So on this side, it's mostly about teaching. So you need to write course proposal, you need to prepare some materials, and you need to teach. On the second part, it's mostly about writing grant proposals. So you need to you need to come up with some idea, and you need to then convince someone that you need money to do this idea. So you need to write the grant proposal. You need to get the funds, you need to get the money, and then you usually read papers, write papers, share results of some conferences, in some journals, mostly collaborate, and this is how you spend like 4 years. So I think that you know this part. So today I would like to show you more about this part, the research part. Let's see. And I've just finished a research proposal called ML Gen 6. So I thought that it would be nice to share with you some feelings, some experience from this particular program, because it has ended. So I think it's a good time to kind of summarize what has happened. And also on the example of this proposal, I would like to share with you few joys. Why actually I think that it's very nice to work in academia, what you can learn here. So first is the long-term planning. My experience from companies is that usually you are working on very short schedules. Like you need to deliver some result in a month or 3 months, maybe 6 months, but usually it's like that. So for research proposal, it's really, in many cases, that lifespan is much longer. So in case of emergency, the idea comes in 2015. The proposal was prepared in 2016. It has started in 2017, and it has finished in 2021. So, no, 7 years, no, 6 years, let's say. You need to plan for 6 years ahead. It's hard, but it's interesting. Like you can really learn useful skills related with this long-term planning. You need to think where you would like to be in 6 years. What you would like to achieve. It's not easy, but by practice you can learn this. So it's fun. This long-term planning, it's not easy, but I think it's one of the nice things about working in academia, because you are not in a rush. You can actually plan many years ahead. Second thing is that you can adapt easily. Like you are working on research, so it's clear for everybody that research is a risk-taking activity, and things might go wrong, or you may get some unexpected results. So based on this particular proposal, initially it was all about genomics, large-scale genomics. So the idea was to take a data about different data from large databases about oncology. In these databases, you can find very detailed descriptions about thousands of patients, dozens of thousands of patients, about their methylation, gene expression, mutations, and you can combine all this information to give some predictive score. And this was the first idea, to do some useful predictive models for oncology. It was a really good idea, but then after some first results, I kind of discovered that, okay, we need to solve maybe a bit easier problem, but without solving the problem, we cannot get a good predictive models. So then it turns out that after a few months, we were working on modification of random forest. Then it turns out that we need to extract some information from random forest, because otherwise these random forests will be useless. And after a few master theses, after a few research collaborations, we found out that we need to explain individual predictions from random forests. And then now we are 3 years after the start of the project. But then we learned that we need to explain predictions that will be easy to understand for physicians. And finally, this year, we end up with a grammar for model explanations. It was very different. This grammar now is used in finance, in some other applications. It's very different from the original idea that we need to do something for oncology. But again, life is about change, and you can experiment freely at academia. So it's happening. Like you are doing these quick evaluations, and it's up to you where the journey will end. The other thing that I like a lot in the work on academia is that you can work in teams, with large teams or small teams, with younger people or older people. Collaborators might be very, very different. So you can find a lot of enthusiasm and energy, mostly in students, PhD students, and you can find a lot of experience and knowledge in older colleagues, more experienced colleagues. So in this proposal, it was like very small proposal, 500,000 Polish zlotys. So it's not a big proposal when compared this to other budgets, but still it was enough to work with 15 collaborators, many PhD students, many students, and it's kind of real fun when you can assemble a team and do whatever you wish. So it's also a part of joy that you can find in academia. And also the last piece, I see that I'm prolongating my part, but it's almost last slide. So the last thing is that actually in this 6 years, you can do something that will stay for hopefully longer. So out of this project, we created, delivered, published 12 research papers. We wrote one book, which is like 300 pages long, hardcover. You can show the book to your family, parents, kids. It's kind of fun. We have few collaborators from abroad, lots of conferences. You can go to Korea, New Zealand, United States, and just meet people, visit nice places, and so on. These things are being used. So here I have some statistics that we have like 100,000 downloads from CRAN and 30,000 downloads from Pi. I don't know how to pronounce this name. It's for Python, sorry. So yeah, you can do things that actually people will be using. So it's actually fun that you see that you have built something that is being used. So probably the part that is closest to you is the part that is related with PhD courses. So maybe some of you think about PhD. So for me, I really like this picture on the right. It's kind of illustrated guide to PhD in one single picture. I don't know whether you know this particular picture, but the story is following that in your primary school, you learn this blue box. You learn more or less something about everything, Polish, English, chemistry, physics, and so on. Then you are going to high school and so on. So you are learning more or less about other things, like, again, more history, more chemistry, more physics. And then you are going to academia, and you are doing more or less specialization. So learning about a very, very, very narrow piece of research. And one day, at the end of the master classes, master courses, you reach this kind of edge of knowledge. And the whole PhD is about making this small change to kind of push this boundary a little further. It won't be a big change, like the whole knowledge, human knowledge. Maybe it won't be that visible, but this will be your change, your piece, your mark. So it's kind of interesting, and I think it gives you a lot of fun. It gives lots of satisfaction. So that's all from my part. Feel free to ask any question after all sessions, or send email to me, or send email to any of our colleagues from MI Square DataLab. I think that many of them will be very happy to discuss things, talk about some doubts, and of course, you never know what is best for you. but it's always good to try interesting things. And yeah, that's all from my side.
Maybe somebody have some questions already? Okay, I think we can continue.
Okay, so I will share my screen now. Oh. Oh. Can you see my screen?
Yes.
Okay, great. So I'm Anna. I made my PhD a lot of years ago. I think it's just like a very old history, because there was no deep learning, and now it is here. So I work a lot. I have a lot of projects when I use deep learning, machine learning, and then it was quite, so maybe only a start of deep learning. So I made a neural network for mammography. So it was medical image processing application and research in my PhD. But then I changed my field completely. I dive into natural language processing and machine learning, and had a lot of projects in industry. About 5 years or even more later, I started to work in academia in our faculty, Mathematics and Information Science. And all the time I have projects in industry, only in cooperation between academia and industry. So it was some startups, some bigger corporations, for example, Allegro. I hope you know this. So it's it's the biggest e-commerce platform in Poland, Eastern Europe, I think. Still the biggest one. And now I work also, I cooperate with Cinerize. It's a smaller company, maybe not startup, but still not so big corporation. And I work there also on, so I will say about one of these projects. So because now I work in 3 projects, it's quite a lot. But I cooperate with a lot of students, with a lot of researchers, and I also think like Przemek that it's fantastic. So because we have many opportunities, I like projects. One of my colleagues said that I'm just like humanities in engineering. So I work with project on text mining and natural language processing. And now I get a grant for well, maybe a small project, but still it's a 2 years project. We already started, we cooperate with the University of Warsaw, and have a group of scientists from our university, from the Faculty of Management, and our faculty, Mathematics and Information Science. And we try to model legal regulations, especially those those in COVID pandemics, but not only, so it's only one example. So we work how law changed during the pandemics. And it's a great concept how to cope with different quality data. So in this project, we have text use case. So we have these legal texts and try to annotate them, extract this knowledge and relations between different entities, concepts. And as you know, as in natural language, it's not so very precise, and the quality of data is very different. And we try to measure the quality, of course, improve the quality of data, and model with machine learning. So now we are at the very beginning. We changed a little bit our primary conception, because we thought that we just we would annotate data, measure the quality, and do so. The next steps of the machine learning process, as you can see in this slide. But after 2 months, we changed that. We started to think that we need something like ontology, that some model of the data and the relationships in the concepts, in the legal rules. And we try to make these extractors, these automatic processes to model the whole knowledge. So not only extract specific names from this text, but also model the relationships between different regulations and entities. And it's very fine for me. So that we have 2 months, and after 2 months we changed a little bit the project, because we in cooperation with the politologists and linguists, we thought that it's better, and that it's better solution for the whole idea of legal regulations modeling. So it's our one project in DataLab, and the next one is somehow connected. So also we try to model text, but these texts are on food safety. So we try to help make systematic reviews, which are commonly made in this organization, which check the safety of food, different chemical substances, if they can be add to our food or supplements and so on. And at the beginning, they have to make reviews on many researches connected with this tests on animals and even people, how these specific substances are safe for people or not, or on how people react to these substances. So I think it's very important, and this is really fantastic project. It's a cooperation of 6 institutions, 3 of them, or 2, I don't remember. So, but some of them are from Norway, because it's a project within Polish, Norwegian grant proposals. And so we cooperate with them, and they work on, of course, there are people from this, I don't know the English name, so in Polish it's some Polish Hygienic Institute when they do this research, and the same similar institute in Norway, and we have to model the process, talk with them how they would make these reviews, and then model the whole system and the process of this automatic procedures, how to help them, how to model the data, extract this specific substances and maybe organs that they influence and so on. So everything which is very important in this domain. So it's, you know, just like modeling the whole process to help these people, these researchers, to make these reviews. And I'm responsible for one task. It's quite a big task. So it's this semantic module to expand queries when they just ask the system about different substances and so on, and to annotate texts of research publications. And of course, we have to have a document database, ontology database, because in medicine there are a lot of ontologies. They try to model these substances, these influences, and so on. So it's also a 2 or even 3-year project, and we are at the beginning, but so the team is great. So a lot of experts in many different domains. Yeah, so in this food safety domain, machine learning, and so on. And the last use case I would like to show you. So this is this project with the industry, with Synerise. And in this project, we try to model different data, images, text, behavioral data, and try to make a common representation for them. I work especially in e-commerce recommendation, but also with behavioral segmentation of clients or products. And its work is based on a big platform of data. A lot of, you know, just like industry, we have access to data of very big companies like Żabka. If you know, there is a food company, food shops in Poland, or the biggest companies like CCC. So it's also a big market of food. I think there is everything. And also we cooperate with the fashion industry, fashion e-commerce shops, and it's really great. So we have big data to work on them. And that's it. If you have any questions, I can tell you something. Have you got any questions? Hello, can you hear me? Or
I can hear you very well. I think that
Yes.
many questions will come to us after the first presentation, but at least I can hear you.
Me too.
okay, so I will stop sharing, but I have to find this. Oh, yeah, okay.
And guys, don't be afraid to ask questions, really. It's like very important to have a dialogue. So, yeah. Okay, I think we can move to the third presentation and then we will start our Q&A session where I will torture.
Okay, so I will start my part. I hope you can see my slides.
Yes, yes.
Okay, great, thank you. I just worry after these two great presentations, maybe I'll jump into too many details, but oh well, at least it will be quick. So don't worry too much. I've heard all these encouragements from Przemek and Anya about working in the academia, and I guess I would encourage you to do that also. I spent many years in the corporate world, and I worked for big corporations and for some startups. And also, I have an experience with one university abroad. I spent many years at Colorado State University in the US. And I've only been at Polytechnica for just above a year. So I think you can do interesting things in whatever you choose, and that I'm not saying that you shouldn't choose academia and Polytechnica, but you should do it based on what you feel like doing. Do you need guidance? Do you like to take initiative? You can have your own space even in a corporation. So if you work long enough, you can get some space to investigate problems, work on your solutions, and have more time. But it's definitely more obvious that it will happen for you if you're at the university. Either way, a PhD helps. So even if you want to do a research in a corporation, there are many R&D departments that will let you do it. Having a PhD really opens a lot of doors. So you're young, you have plenty of time, definitely consider it. One thing I would definitely like to encourage you to do is study math and statistics. And you're data scientists. I know that machine learning is big. Yes, everybody likes these cool projects, NLP and image processing. I personally like math and statistics. Well, I wrote all these things, why it's important, right? It's at the core of many algorithms we use, and it really explains how we should collect data and how we should make inference from the data. But it makes us sensitive to a deluge of information. Yes, we can tell facts from fiction. We learn to be skeptical and ask questions. So that's something that even with your focus, if you have a focus on machine learning, just don't neglect the background and math and statistics. And if you do choose to work here, Polytechnica is really a great place. And like I said, I've only been here for just above a year, and I'm involved in so many things because there are so many projects, there are interesting people, and you can really try to make a difference. Most of the projects these days, they hard. Yes, if you really want to change the world, you have to gain a lot of knowledge and work on your domain knowledge. I remember this one really great keynote speech at the JSM, which is really the biggest statistical conference when the speaker was giving us some example of how we could make a difference. And the projects he listed were just huge. Like I remember a couple, like financial fraud, which probably would require that we study finances for 5 years to really understand all the details. And there were also some employment statistics, also not easy to estimate unemployment. So projects now are not easy. They require a big group of people, and they require deep knowledge, and that's why being in a university or technical university will give you these options, will inspire you, hopefully, give you exposure to many problems, and let you work on a team where people are interested in similar ideas. But since many of problems we need to solve, they require cooperation with the government, with NGOs and corporations, we would also like the people on those other sides to be smart and knowledgeable. So wherever you go, you can make a difference. So just choose wisely. And even in our at Polytechnica, you can choose from many labs that do various things. And as an example, just projects that I've been exposed to and problems, there are many scientists who come with problems and they need help. So these are just a couple examples that I dealt with so far. The first one I will talk in more detail since we spent a few months analyzing some COVID data, and maybe there will be some publication from it, maybe not. That depends if we get more information from the government. But we're often asked to help with actual research of medical professionals, and a lot of the time these are just observational studies, so we get to make some inference from the data that people collected. But scientists from medical academy in Warsaw, they also work on new treatments. So if you want to make a difference in medicine and really help design new treatments, test new medications, you'll get plenty of opportunities to help. Yes, and some of those problems, yes, they really improve lives or save lives. Sometimes questions, they very small, but you still help. And not all of them are related to medicine. There was one really interesting problem I had to help with recently. One gentleman brought some data that he received from a company, and he really suspected the data is fake, that somebody tampered with it, and he needed a statistician to confirm that. So maybe that's not a frequent problem, but it also happens, and it's good to be able to help. Now I move on to the real problem we worked on, and yes, I didn't have as many opportunities as Przemek or Anna to work on those various issues. This is really the COVID study, the major project I worked on so far, but we have a couple more grants in the making. So we applied for a few grants. So there is hope there will be just more interesting collaboration. But the COVID study is important because, as you know, it impacts our lives, and we would like to go back to the normal life, right? and the lockdown does not seem to be ending anytime soon. It's just been extended. But the first data we got, so I will talk about how the study started and how I go about such a research, what I do. So if there is too much theory, then, you know, just take a look and don't ask questions if you need to, or read about it later, or just ignore it if you don't find it interesting. But I'll give one example of this complete study we did. And we received pretty detailed data of COVID patients. It was about in summer of last year. It turned out it didn't last. The data only covered the initial 6 months, but we got a lot of information, the demographics. So this is stuff you don't see on the website. This is the stuff that nobody but the government and us had access to. And that's also to show you that if you're a part of an organization or of a university, you could get access to some sensitive data. Of course, it will be anonymized often, or you will be responsible for anonymization, but you could see the data that nobody else can see. But also in this case, we wish we could have more, or that there was some two-way communication, that as causes were more obvious, we could ask for different information to be collected. Yes, we had age and sex and the profession, but we could also now want to know whether a person was a smoker or was obese or had children in the house, because that would let us give better answers of how the disease spreads. Yes, and how people react to it. So we could really only give those answers based on what we had. And if there were knowledgeable people like you in the government or in NGOs or in other places, yes, we could have a better communication and better results, right? We could really solve problems for the benefit of everybody. And again, just some information about people who were sick. It seemed to correspond to ages in the society, so we couldn't really tell that the disease, at least in the first 6 months, that it affects any particular age groups more, right? This is, I think that the age pyramid in Poland might be about that size or that shape. But what's important when you approach a new problem is to get some good theoretical foundations. And survival analysis, it's one tool that I like to use. It's very powerful for observational studies or experimental studies, and it's based on stochastic processes. And stochastic processes is this framework that really lets us describe a lot of natural phenomena. It helps us draw inference from life events, from people's health and people's behavior. It's really a powerful mechanism to describe and analyze various processes. And here are just some examples of various stochastic processes. You'll see them in biology, how a bacteria grows or viruses. Brownian motion is something you'll see in finances that looks kind of like some stock. Yes, it's daily changes. And there is a very popular tool, a Poisson process, that lets us do some analysis when we count events like diseases. So now we're all used to the numbers. Yes, we count the sick, we count the the dead. Unfortunately, we count the recovered. So the framework to do it, there are some signals and there is noise, and we have to learn how to tell the signal from the noise. Another important parts of the survival analysis is this looking at events in people's lives. And although the vocabulary is sort of life and death related, we could study time to any event, buying a home, finding a job. This is really how we approach this. We talk about a survival function and a hazard rate, and we can describe a lot of life phenomena. Finding a job, yes, maybe it's your first job. The hazard grows, but then as you're not finding it, it goes down. So you can infer these rates, these patterns from the data. And sometimes we're interested in more event than one. So there are also models for that. Some typical models, we deal with illness, death, or competing risks. But in the case of COVID, we were interested, for example, one of the problems we looked at, what happens to people with symptoms? Once people have symptoms, what happens to them? Do they recover? Do they go to hospital? And what's the likelihood and what it depends on? So using all the framework I just mentioned, the tools, we could draw these pictures and even put the numbers behind them that I'm not gonna do here, but you can see graphically how various diseases people have, like obesity or cardiological problems, how they impact the probability to end up in a hospital if you have symptoms. So on the left, we see people who are pretty healthy for various age groups and sex, men and women. They seem to, at least early on, they seem to do pretty much alike. I know I'm running out of time, so just one more slide. But with age, women seem to do much better than men, and you can see it in the data. And something I found surprising is that the top priority when people go to the hospital is about 10 days, maybe slightly after the 10 days for healthy people. They were healthy before they caught COVID. And for people who had some pre-existing conditions, it's just below 10 days. So this information you can extract from the data if you use the proper tools. And if you work at Polytechnica, you'll get access to the data, and you'll get an opportunity to really extract or infer useful information that can be used to help. And I have some other slides, but I really skip them because I think you can just show them probability of death under various conditions, and also probability to find a place in the hospital based on where you live. And which was also a surprise to me, that living in a big city like Warsaw, you don't really get the best chance to be admitted to the hospital. Sometimes smaller cities are better. But that's about all I wanted to show you. So hope it was not too boring.
I have one question already, sorry.
Mhm.
Like you said about in the big cities, it is hard to be admitted to the hospital, but what about recovery? Maybe the medicine is better in the big cities?
Well, so I guess here the two slides I had was hospitalization and death. Also, people in big cities had a higher chance to die. So it seemed here that in smaller cities, people with, but these were people with pre-existing condition, right? And maybe we would, I guess I don't have that maybe people are healthier and fewer of them have these pre-existing conditions. I'm not saying that because that's not something I examined here, but at least for people who are already sick, being in a big city really didn't help them. And living in a city that's here, if you see in blue, it's about 50 to 100,000. So it's big enough that it will have a hospital and it will have the proper infrastructure, but it's not too big to be stressful, and maybe you just in general, you spend less time in a car commuting to work, or or relatively you get more infrastructure in a smaller city than you have in a city like Warsaw or Krakow or Wrocław, because yeah, that's my guess that this is really what causes it.
Thank you.
Okay, so I'll stop sharing, because if you have questions to other speakers, then maybe they'll show their presentation.
I have a question. Did the government use your analysis in order to act differently, or you just made those analysis for the science purposes?
This was really just for science purposes. There is this other group, MOCOS, that's led by Professor Till Kruger, and they work on to analyze the actual spread and what helps with limiting the spread of the infection. And we know that they were somewhat listened to, but more often than that, the government really decided to do something else that was politically more viable for them. Or so there is also a part that could be frustrating, but we can't make a change immediately, right? That's why there is a room for you to come and join us and yeah, change how things work.
If I may add something to this answer, is to share with you a single website. Let me just share this with you. Actually, we have few projects related with COVID. Ella showed you some of them, but there is more. So you will find a COVID against MI Square against COVID initiative, in which we have actually six projects. One is collaboration with MOCOS group to do some data-driven predictions about number of infections, but also what I found interesting, we have like two other initiatives. One is related with estimation of individual risk of being sick or having some serious outcomes like death or hospitalization. So there is a personalized calculator of your risk based on the Polish data, and you can choose some information about you, and then you can calculate your scores. It is not easy to operate on this on iPad. And second thing that we are doing right now is the monitor for new variants. I guess that you know that the largest risk currently is that new mutations in COVID will help the virus to go to go away from immunization provided by contacts with previous variants. So it's really important to monitor the current situation. So actually, 4 students from IAT, from second and third year, created a website. This is the website in which you can find detailed information about different countries in Europe, what is the state, what is the share of different variants in different countries in a given day. And this monitor is being used by Ministry of Health. I'm not saying that they are doing good decisions based on the monitor. It's kind of out of our reach, but at least we can provide data, and they can at least consult their opinions with the data. So this is something that is happening, and it's not that we are doing this analysis for our own interests, which is also okay, but these things are actually being used, and it's also part of the fun.
Mhm.
Okay, thank you. It was very exciting.
Maybe some other people have questions?
Yes, I've got a question too.
Yep.
So did you have issues with missing values in comorbid diseases? Because sometimes people are just not diagnosed with a disease that they already have, or is it maybe not that important because that means that maybe the disease is not advanced enough?
So that set that we analyzed, it was, so this was really just the initial 6 months. And by that time, Sanepid, which I hope you know what it is, it's this body that initially was supposed to track the contacts and write down information. This was really about the time that they were still keeping up. And they were trying to write down all the information they could about a person. There are people who got caught in the system even without symptoms. So some testing was done of family members, and there were people who were positive but had no symptoms. So we have the information about these people. There is some missing data, but at least for that time, we also think the data is trustworthy and as complete as it could be. But obviously, we don't have all the people who were infected at the time, but were not diagnosed or had no test or for other reasons. Yeah, so the data is kind of what it is, and if that pace and accuracy was kept up, it would have been great. But right after that time, there was a spike, and Sanepid wasn't keeping up and stopped testing enough people and tracking their contacts. So the situation really got out of control. But even knowing that the data wouldn't be perfect, I'd like to see it and do some analysis. So yes.
Thank you.
Any other volunteers?
Okay, maybe I have a question. I will show myself for a moment. Hello. I have a question about how to become a data scientist when you are not a student anymore. Because when you are a computer science student, it's much easier to start with some project or get help from your teacher. And when you are in the position like me, for example, when you are not a computer scientist, I am a biologist and I would like to start a career in data science. How can you advise me to start?
Who is going to start?
Well,
I can start.
okay.
So learn how to program. This will be the first thing. And I guess that Ella will tell you learn math. So maybe this is complementary. But I think it's really important to automate things. And to do data science, you need to automate things. So to automate things, you need to be a good programmer. Maybe not a software developer, so you don't need to work by writing software, but I think it's important to learn well a language like R or Python, and then of course learn statistics. But sometimes it's easier, sometimes harder. Actually, I know a lot of people that graduated in either physics or in biology, who have this drive for data-driven analysis. Because in physics, and I think it's also in biology, you are kind of trained that you need to do experiments and then extract some information from experiments. So you have already the understanding of this interaction between data, experiment, and the reasoning. But what is common, you need to improve skills in the programming, because it's really hard to do good science currently without programming. So
I will say that I already started that because I was a PhD student for some time and I needed to learn some R programming. So I started, and now I'm starting to learn Python, but it's hard to someone who isn't longer connected to academia or like professionals in concrete space, like data science, to, I don't know, find myself into community. I don't know.
Yeah, so I would like to use your case as an advertisement for students that you are in a good position to actually do this project. So take this opportunity. But of course, after graduation, it's still a lot of opportunities. Currently, it's not that easy because we are locked in houses. But I think that there are great initiatives like hackathons, and sometimes you can find a nice team or a group of people in certain activities, and then through these people you can learn about new opportunities. So yeah, I think that this might be interesting. Also, I know that some universities like University of Warsaw, they have open courses for people outside of the university. So you can apply for this course. They are either free or you can pay like 100 zlotys for semester, so they are not very costly, but you have access to these researchers and these academics. And I think that this might be a good approach to sign for these courses, to be recognized somehow with good, I don't know, projects or something, and then ask for a project. Many people in academia are looking for juniors that would like to help them with, I don't know, analysis, exploration. There is a lot of things that has to be done, and actually currently these data science teams are pretty large, so you always need help. So I think that my advice would be to be involved in something, be recognized, and then people will help you to develop further. Ask questions.
Thank you. It's very interesting.
I don't know if Anna or Ella agree or not.
No,
I
those
think
are,
you
I
can,
think, go ahead.
sorry. I think you can also attend seminars in DataLab. So every Monday at 10 we have seminars, and you can join, or you can even choose some online courses. For example, at Coursera, there are a lot of fine courses on programming in Python, R, or deep learning, and so on. So you can start this way.
I already done that.
Oh, great.
Yeah, I'm a big believer in a real school, and if you're just doing a course where nobody grades you, it's hard to be motivated for a long time. But just something to consider, maybe you could get a master's in data science. These are available, right? Or a PhD, but maybe master's is a good start. First, to see if you really like it, because I guess it's hard to advertise a real school if we're all remote, and there doesn't seem to be a big difference between a Coursera or Warsaw University, but hopefully, it will go back to normal, and a constant contact and interaction with teachers, students. I don't think you can beat that, really. So maybe something to consider.
Yes, that will be helpful to be in a normal situation when you can talk to someone in person.
Mm-hmm.
Thank you very much for your answers.
If I can, I would like also to add one sentence because my friend was in the same situation, and he was just the normal case. He was like studying chemistry, if I'm not mistaken. And after he graduated, he just started to like stalk some professors at the universities, read his or her papers, and afterwards just wrote an email and said, okay, I like your paper X because like this is a nice and I like this and that. And may I join your research? I would like to develop this or that idea. And after writing papers with him or her, he was like already in this environment, let's say like this, and it was much more easier to move forward in the scientific world. But it's just, yeah, sorry.
Yeah, that's an interesting way.
Maybe other people have questions.
I have a question from the opposite point of view, because I'm currently in my third year of studies. And if I want to get into academia, what is the best way to start now? As I'm only starting, I'm currently facing a challenge of selecting a topic for my engineering thesis, and how to find a good topic, how to get into scientific work.
Who is going to be first?
You.
Okay, let's do it. I think that the best way to find a good topic is to try many topics, and simply. I know that many research groups are looking for people for summer projects, and at our university there should be some special list of research activities that you can do during the summer in the POP, cybersecurity and data science. There is a POP, and we'll announce a program. It will be called Solaris, and this will be a program that should help students to get involved in some research during the study, because actually this is the best place to try whatever research is for you or not, because it's not for everybody for many different reasons. But you never know. So the best idea maybe is to start to do something during the summer. And MI2 DataLab is not the only lab in which you can do the research, but we will have such research program. So, and I think that we have talked at LinkedIn. So, so you are on good track. But other groups are also looking for people, and I think that March, April, May, this is a good time to maybe ask some people that are doing interesting research, whatever they will be looking for some, whatever they offer some internships during the summer, and you can do a lot during these 2-3 months. Yeah, and this is, I think, the best way. It might be that you will end up with some completely different research area after the research. It might be that between the bachelor and master, you will switch objectives and do other things, but the approach, the understanding what is happening in academia, I think it's more or less common, even between different domains. So I think it's good to have experience, research experience, and it might be in the wet lab, in some biological institute, or in the dry lab, like MI2, or in some other labs more oriented on learning or more oriented in, I don't know, mathematics. Yeah, just look for such offers, especially during the summer. I think that this is a very good period, and you can try global initiatives like Google Summer of Code. So you can do this internship not only in Poland and in Warsaw. You can do this in Stanford, Berkeley. It's maybe harder, because lots of people are applying there. But I think that especially students at our department, they're really well trained. So you can really try to do these research activities in very, very good places, and you can apply there. So yeah, apply, try, and choose the best position that you can get.
Okay, thank you.
I don't know, Ella and Anya, whether you agree or not.
No, that's perfect. I think you got it. So yes, try things because yeah, and having classes, I guess that's my experience from a grad school is that you take classes and you learn what professors do, and just by taking classes, you you either like something or you don't, but you get an idea and you get to know the person and maybe approach them and see if they working on something that you could help.
So maybe I give you an example. So I was very happy a month ago because 3 students from the 3rd year just wrote to me that they would like to do something interesting, and I just have some slots in my projects, and I gave some tasks in within my project, and they are very happy that they can do something usable that is just practical things. And on the other hand, I'm very happy that there are people and they are very so, you know, because I think that students are very enthusiastic and I like to work with them. So I think that it's a so win-win solution for everyone. Yeah. And so I gave them very hard task, but you know, students never said, "Oh, I cannot do. I have no time." They just start to to do things, and it's fantastic. And I think that every one of us is very happy. So just to go and ask professors, other lecturers, and so on, and I think that they will be very happy when you just ask and for any project, any idea to work.
Okay, thank you very much. All your advice were very helpful.
Some other questions? Okay, Valeria, maybe you have some for our speakers?
Some questions? Okay, probably it will be quite different than another question. But why you choose to work in a lab in a science, not like a big corporation? Because I'm a freshman in uni, and I like that atmosphere, and I would like to work in uni too. But I would like to hear someone who is like much experienced and older than me. Which benefits to work in uni or in science, not in corporations?
Well, okay, I'll start since I worked in a big corporation. I guess there really isn't a good one reason to work here or there that would be a reason for everybody, because it's all very individual. Do you like guidance? Do you like to kind of slowly grow into an organization, be told what to do? Do you like teaching? Because teaching is probably a big factor initially. What other differences I can think of. I think in a corporation, you can sort of focus on your task at hand. And at the university, there are so many different things. There is teaching, there are projects, there are grants, there are conferences. So research life is just, you could say it's richer, but it's also full of distractions. So it really depends what you like and how you like to work. And I don't even want to get into some financial issues because I'm sure they matter for people, but it also depends on the place, on the company, right? Depends on the university. So these things can vary. But there is just a very different approach to your tasks, what you're supposed to do. Whether somebody controls your schedule, your tasks, your development, or you want to be in control of it for yourself. You have plans, ideas, you know what you would want to work on. Yes, you have some ideas. You think, I really would like to research certain things. So it's really will be something you need to ask yourself. Yes, have a conversation with yourself. What do you want yourself to do in 5 years or 10 years? What would be fun for you?
Okay, thank you very much.
I think that in academia there are more cutting edge projects, so not so common standard solutions just to work, but very new ideas, a lot of new ideas. And it's true that there are a lot of distractions, but on the other hand, there are a lot of collaborators, a lot of different people, characters, many enthusiastic students, maybe not all of them, but I think that most of them are very enthusiastic. And the life is very dynamic, And when I worked in corporation, it was slow. I have a lot of ideas, and my boss said, "Oh no, Anna, no, it's enough, not this idea. No, we can do this." And I felt so stopped, always, not this time, not this idea, And here we have a lot of ideas, and we can change. Sometimes we can change the area project, so teaching or other domain, so it's more, so sometimes it's extremely dynamic, but I think it's more lively.
Okay, thanks.
And if I can add something to this, I think that at least for me, what I like is the full control. Like on the beginning, maybe it's not that much control that you have during the PhD or something, because you need to learn a lot. But then you really can choose anything. Like you can change university, go for sabbatical, go for company, return to university, have more teaching, have less teaching. You really have a lot of control on your life. And you can also find such position at in corporation, of course. And I guess for different corporations, it will be more or less easier. It might vary a lot. But at least for me, what is nice is that you can really do anything. Like you can invent your own course and to have a course about design thinking, for example, or programming or new language. Like sky the limit, and it's always about your development. So it's clear for people at academia that we are here because we like to learn things and develop personal development. So when you sign something, when you publish something, it's like it's your result, not your company. Of course, there is some affiliation, but it's your brand, and you are working on your brand. So at least for me, it's important. But
Yes, true. Thanks.
Maybe one maybe final question, because we're going to the end of the meeting. A little bit more spicy question. What about the competition between in the scientific field? Because is there is like a competitor feeling, something like this?
So I think we have some competition, but still there are a lot of areas in science that I think it's, for me, it's not so important. Yeah. So just, there are so many people, so many students that we really, for everyone, there is a small, even a small field. Yeah. So I don't feel this that I have a lot of competitors and I need to be better, because I can find something for me. Yes, it's not so important. And sometimes there are a lot of open people, and they are very helpful. They often would like to advise you, and for me it's very important.
Mm-hmm. Maybe I just watched too many movies or read too many books. Yeah.
If I can add something to this, I think it may depend a lot where you are working, in which group you are working. It might be huge variation. And I think that you can find groups, MIT is known for this, that will be super competitive. And it will be super, huge pressure for results, huge pressure, much farther than in any corporation you can imagine. But also you can find places in which it's more about collaboration. So as in business, but maybe the variation even larger at academia, that you can find places in competition is really high, and places in there is no competition, is more about collaboration. So you can kind of choose. And also sometimes competition is good because it helps to develop to some level, but the level is different for different persons. So yeah, I think that you can choose your level of competition in academia as well.
I see. It's very flexible. Okay, guys, maybe any other questions? And maybe Valeria, some final words.
Okay, so I can say only thank you for our experts and for our visitors, and I hope we will see each other again. Thank you very much.
Thank you very much.
Thank you so much.
Thank you a lot for coming. See you in the next meeting. Bye.
Bye.